Good morning, everyone. So today let's start working on another LeetCode quiz again. Let's do pick one randomly. This is an easy one, so let's skip. Hard one, let's skip it as well. Okay, medium. Let's look at the question. So this question is rotate list. Given the head of a linked list, rotate the list to the right by K places. Here's an example. So let's say the original linked list is 1, 2, 3, 4, 5. And K is 2. K is 2 means we need every node in the list move right by 2 places, right? So which means that in the original list, 1 is in the first place. And after rotation, 1 should be the third place. Originally 2 is in the second place, and after rotation, 2 should be the fourth place. Okay, I think the requirement itself is pretty straightforward. And let's see. So the input is the head and the element. The head is a list node. A is int. Again, let's think about how we want to handle this question first. So the first step, I think, is we need to find the length of the list, right? And connect the tail to the head to form a circle. Because circle is easier to, to rotate by several places. So let's write down our main strategy for reference. So find length of the list and connect the tail to the height to form a circle. And then we need to calculate the new tail position, right? Calculate the new tail position. By K. So after we form a circle, we need to know where is tail position. So the length. And also that we need to think about the K can be, sometimes can be, let's say 100, 1000, right? It can be pretty big. So we K mode length, right? If it's 2 or it's 7, it's 12 and minus 1, right? Because the index start from 0. And then we need to break the circle, right? As a new tail and return the new head. Sounds good? Okay, this is the definition of the list. And this is its rotation. So firstly, let's check some edge cases, right? If not head or not head next. Which means that there's no head or just one node, right? Or K is equal to 0. Then what happened? Just return it, right? Because there's nothing to rotate. And then for most of the cases, we need to find the length and we need to find the tail, correct? So let's store the old head first and initialize the length as 1. Then what do we need to do? We need to calculate the length of the list. So go to the next one and go to the next one, put it, and increase the indicator. And now we need to make it a circle, right? How to make it a circle? It's to make the tail as a head. Right? Because at the end of the day, it's just like a pointer. We point the head to the tail. And then what we need to do, we need to do a K places right move. So the main idea to find the new tail and the new head, right? And because we have no idea how length it is, so we need to use key mode length. And we can put the new tail point to head again, right? And then we can use a we can use a loop to find the new tail and the new head. So for any element, right? We get a new tail. Right, for the first, because basically the circle can be divided in two parts. Before the part before movement and the part after movement. And we put the tail. So basically this is dual left movement, right? Because dual left movement basically is the same as dual right movement. And then the new head would be the new tail. And then break the circle. Right, stop here. Then return the new head. Let's review what we've done here. The basic idea is we want to move every element in the list, linked list, to the right. Because if you think about the direction, right, it's the next node will point to the previous node. So it's easier to do a left movement, right, rather than a right movement, because the linked is in this direction. So that's why instead of the right move K places, we left moved length minus K, right? If K is smaller than length. So I think that this is a main trick of this algorithm. Again, let's explain the code and give test cases to demonstrate the algorithm. Right, and let's oh yeah, wait, let's run it first. Okay, cool. Okay, asset. So I think that ChatGPT explains the algorithm pretty clear here. The first one, handle edge cases, right? If the list is empty, which means the head is none, or has only one node, or case equal to 0, then the rotation doesn't change anything. And the second step is find the length and the last node. We will traverse the list to find its length and the last node. So step 3 is to make the list circular. We connect the tail to the node, right? Because at the end of the day, it's actually kind of like a pointer. So the head will point to, to the next element of the old tail. Well, actually, I think that yeah, I'm thinking about is this, I should call this as a pointer or no? And the step 4 is to find the new tail and the new head, right? Since rotating right by k is the same as moving the head left by length minus k mod length, right? Then we can move length minus k minus 1 steps from the head to reach the new tail, right? Because it's a new circle. And step 5 breaks the circle, which means we will set the new tail's next element at 0, right, to restore it as a normal list. I think that we can also ask it to explain the data structure and the building functions in this code, right? So we can understand, the theory much better. Yeah, so here it give test cases, right? Case 1. Well, I should be more specific. What I want to say is a step-by-step test cases. This test case actually doesn't, explain anything very well. Well, visualize the example. That's good. So you see we have 5 elements here, right? And they point to the next one. So we connect them in a circle. And we need to find the new tail, right? So how to find it? Originally 5 is new tail, but we move them 3 steps back. So which means 5 will become 2. which is node 3, right? Because remember, it's the index start from 0. And then 3, because 3 is a new tail, then the new head will be 4, right? This next one. Then we break from here. So the new circle, the new list will start from 4. Okay, and the data structure knowledge we need to know here is singly linked list. So a singly linked list is actually a linear data structure where each element stores two things. First one is a value. Second one is a reference. Basically, it's a pointer, right, to the next node. And this is how the initialization looks like. And here is an example, right? If we create a singly linked list. And the ABC. And the structure is, yeah. B will be the next one. So A's next one is B, B's next one is C, right? And then C's next one is none. And this is code flow. Head is the first node in the linked list, and K is the number of node rotation to perform. Node head is to check if the list is empty. Node head dot next is check if only one node exists, right? K is equal to 0. Yeah, this basically actually is to explain the code once again. Yeah. Yeah, so here are some, this is what we need to figure out is some building, functions and operations we use here. They are very helpful. So not, right, it's a Boolean negation, or is a logical or. And mod is modulars. And while is a loop. And for and score in range, it's a loop with counter. And this means basically need to loop every element in this range. Return exit function, non-special constant, .next attribute access, equal assignment. Yeah, I think this is pretty a very thorough discussion. Okay, thank you.